I would like to introduce our next speakers, Anirudh, Koul, and Yamamoto from Microsoft. Anirudh is a senior data scientist at Microsoft and founder of Seeing Eye. So Seeing Eye is this camera app. It's available at least on iTunes. I'm not sure if it's on Android yet. Very, very cool app. It's designed for the blind and low vision community. So it's an app that really does social good. It does good for people. It helps describe nearby people, texts, and objects for those people that don't have the same vision that you and I might have. So very, very cool app. Jin is a principal program manager at Microsoft on the computer vision team. And he specializes in OCR technologies. So I'm going to refer to Anirudh as Koul. So Koul and Jin, we're going to tell us about Microsoft's approach to computer vision and deep learning, that solutions that run in the cloud and maybe some on the edge. So we'll hear more about that. Let's welcome Anirudh and Jin.
Okay. My name is Yamamoto. So I'm the program manager on the computer vision team at Microsoft. Hopefully this title with the word cloud in it didn't scare too many people, but I hope you'll see a good sense of the direction that we are thinking about in this space. I think all of us are very excited about this, the vision space, and especially going towards the edge. For hopefully many of you who may have seen our biggest developer conference earlier this month in Seattle at Build, our CEO as well as Scott Guthrie, our EVP for Azure, really emphasized the point that the computers are everywhere. The edge computing really is the up and coming a huge opportunity for Microsoft. So the computer vision will be aligned with that technology. So I hope we can give you a little preview of that direction. So before I kind of dive into the vision aspect of it, Microsoft, under the umbrella of a product called Cognitive Services, we actually offer many cognitive capabilities beyond vision. So the speech, understanding, letting the computer hear your users, be able to respond to the users with voice, or understand who the speaker is, or filter the noise. That kind of speech technology is also part. Similarly, for language understanding, translations, or understanding the intent of the user's voice, or the speech or the text. Knowledge, this is another aspect that I think Microsoft has a strength, which is all these entities, places, people, and objects that you recognize or identify through these other sensory capabilities. How do you bring greater context into it so that we bring the knowledge base from academia, on the internet, as well as even custom made knowledge graph in order to put more context into those entities that you find. And finally, we also have a search engine which can enrich your scenario with a vast quantity of images, websites, and videos and news that's available on the internet, and we make it available for you very conveniently. So now, focusing on vision, we offer our products in three major umbrellas. So the first one is a fairly broad one, but the computer vision umbrella, we cover a lot of, I dare say, basic, nonetheless very critical image understanding capabilities, like describing the image, extracting text out of it from OCR, as I was introduced. That's my specialty. And even sort of more advanced from that, understanding the content within the image. And I'll show some examples of how these outputs would look like, as well as some prototypical examples of how these are being leveraged in real solutions. Face, starting from sort of the foundational things, being able to identify and analyze the faces that's in an image, how many faces there are, do they have, what's their hair color, do they wear makeup, do they have glasses, things of the nature, if you register your faces with our service, with as few as one actually image per person, we can start recognizing them, and having recognized the actual faces, we can make verifications, comparisons. And all of those actually is accompanied by a more of maybe a human element to it. We actually also can attach emotion analysis to those. And finally, the first two, computer vision and face, is essentially pre-trained models that we make it available through our API. Custom vision is a little bit different in that this is really a tool for people like you who are looking for high precision image classifier and or object detector, that you bring your own data and train the model through our platform so that it will recognize the concepts that you're interested in. So it's a vision conference. Better to start with pictures. If you have an image like that, this is just a stylized output that you would get from our services. So having seen that image, we'll notice that it's probably a black and white image with skyscrapers in the background. One of the, I think the best, it's a Microsoft internal usage, but one of the most inspiring and the best use for this technology actually is in PowerPoint, where when the users attach images, we actually run these services to attach a natural captions to it so that the people can actually find the slide and the image a little bit easier using their natural language search queries, or improve accessibility, because having attached this kind of natural language descriptions to the images, we can actually let the people who cannot see understand what is in the image. Next is image analysis, starting with fairly basic ones like analyzing the colors, as well as categorizing into what kind of image it might be. We also offer as a part of content moderation, content understanding, we offer scores like the adultness score. And this capability has been adopted by solution or service providers who deal with user-generated contents. And they want to have a scalable and hopefully a low barrier way to ensure that the users are not uploading images that are not detrimental to their services or their branding or their reputations. OCR, this is my specialty. The text that's in the image is actually not machine readable unless you do an OCR to it. So if you run the OCR, you will get on the output the text as well as its location, the images. These things have a wide range of utilities, from enabling better search for image collections, or at least, being able to form like a collection of images that are more logically grouped together, to more advanced, especially in business processing like receipt processing or invoice processing. You can actually do a lot of automation and improve accuracy as well as throughput of that kind of processing by understanding what is actually in the image in form of text. Switching over to face. So having an image with faces, we assign each of the faces a unique identifier, and for each of those identified faces, we can attach a lot of analysis as information about those faces. Like, again, as I mentioned before, what's the hair color? Does it have glasses? Do they wear makeup? And having a emotion, this can actually be applied in a scenario like maybe you operate a supermarket, you have a checkout lanes, you want to know generally what's the emotions of the customers, and if the many customers are either neutral or looking slightly dissatisfied, perhaps you need to ring a bell and bring in additional cashiers to speed up the checkout process. And as I mentioned, having even just as few as one image per person, we can actually start recognizing those people. Of course, more samples you give with varying angles, our accuracy as well as the breadth of sort of perspectives that we can correctly recognize improves. But having the ability to recognize, if you give us a pair of images, we can validate whether those two belong to the same person. So this technology has been adopted by Uber, who uses this technology to verify that the drivers who are driving the car is actually the person that they've registered as drivers in their system. Now, onto the custom vision, and hopefully you'll take my word for it that we're getting closer to the edge. We give you the ability to build your own custom classifier or object detector in basically 3 steps. You take your own set of images that portrays the positive and the negatives, or the types of concepts that you actually want to classify, and you upload those images to our service. Provide either labels, or we even give you hopefully an intelligent pre-labeling so that it will speed up your process. And you take these images, you train our models, and once we're done, you can actually provide the real samples that you'd like to evaluate. And along the way, not only that you can check the results of our prediction, but based on our output, as well as your targeted feedback, we employ active learning and give you the exposure to what we believe is the most informative image that we may have missed, that if you can give us the truth of that value, that we can improve the model even better. So with this, you can actually rapidly improve the quality of the model. And of course, we also give you a knob to tune between the precision and recall of the model so that you can be in control of the custom models that you build yourself. So I think we want to just briefly talk about, these are all cloud services. I think we have 3 powerful reasons that we'd want as many developers and solution providers to pick up on this and building their solutions. So I think one is it's very easy. These are all REST APIs. It should get you started. Just you sign up with a key and you can immediately start building. And it's also friendly to your wallet. Our most expensive API is $2.50 for 1,000 calls. Most of our functions are even less than that. We also offer flexibility. You can choose your platform. Previously, you may have impression Microsoft is Windows, but of course, in this day and age, we support Android as well as iOS. And you can choose your own language as well as the platform. And as I explained to you, even within Vision, we offer a very broad set of capabilities, and we even added our service to actually let you customize. And finally, we have more than 25 years ago, Microsoft Research was founded to really, under the vision of Bill Gates, to advance the cutting edge research into the computer science. So we have actually taken a lot of those expertise, as well as the cloud operation expertise in Azure, and actually built these models and offer them as services to the public. And we have a community as well as the support that's robust to make sure that when you need help, you actually have them. So one more reason for this audience I hope is most exciting. We announced this a little bit earlier in this month at the Build conference, but we now actually want to make these available for you to run it on your edge under your own control. As some of the previous speakers have mentioned, I think it is, for some use scenarios, it's very, very, very vital that the user themselves make complete control and security over the images and the IP that's associated with it, or it could be confidentiality or sensitivities. So we actually give you the ability to take the models from the custom vision service and deploy it on your own to your own private cloud or on the edge. So this is available today. This was announced earlier this month. It just lets you be in control as you should be instead of the public cloud. So this is sort of the direction that we're headed. And with that note, the examples that I gave you, the one thing that I've sort of personally felt on a day-to-day involvement in this computer vision space, these examples of customer adaptations tend to be very much about automation, efficiency gains. So with that, I wanted to pass to my colleague Anirudh, who will talk about seeing AI, which I hope is a more of a inspirational and a very creative use that's a little bit more human than automating human tasks that are mundane.
Awesome. Hey, thanks everyone. So with that, we'll actually talk about seeing AI seeing AI. I mean, the name gives it away. There's something with computer vision. There's something with deep learning. So this is a talking camera app for the blind community. It speaks what it sees and gives the power to somebody with a visual impairment to maybe learn more about the environment than they probably know about already. So it's like a Swiss Army knife of different tools in your pocket. You know, if you want to read something, maybe it gives you some tools around that. If you want to understand objects and their relationships in the world, it gives you some tools around that. And maybe if you have that inaccessible currency note in your pocket, it gives you tools around that. So maybe let's see a couple of things in action. It's more exciting if, maybe after the event, you can see it in person on the phone. But the very starting point of this is, as an example, is captioning, which has huge, huge value. So in the first example, probably a group of people with luggage at an airport. So you usually see examples of, individual objects tagged. But now you're trying to create a sentence and have the full relationship between that. I mean, that is something that can have huge value. So it's kind of considering that people often think that this as a Turing test if the computer is really unable to understand what the scene is. Reality is it's like a 3-year-old right now. It has seen some amount of the world. It probably recognizes not just objects, but entities. So if you have Golden Gate Bridge, it's not a bridge. So you try to go beyond just general object recognition. If you have, let's say, Barack Obama, he is not just a person, he is Barack Obama. So try to understand faces. So using an entity graph, a visual entity graph, if you will, and trying to put it into relationship between things. So you might know of the Microsoft COCO dataset that we open sourced back in 2014, which serves today as the benchmark for training your own many of the computer vision models. But year after year after year, we have been trying to improve the learning on it, as well as obviously add more to it. So a quick example of this was there's a professor in Puerto Rico who got lost during the hurricanes. And he used the app and the scene captioning mode to avoid fallen trees and fallen power lines. Just imagine that for a second. That was like something really cool we heard. Another example being what you can do with faces. So in this example, it says a 31-year-old male with mustache, wearing glasses, looking happy. You're not going to touch everything and understand that, so it's giving you that facial cues. So we have a salesman who changes his sales pitch based on the customer in front, so they can really make some small talk around. I'll actually go and maybe hopefully show you some of the videos here. All right, so here's a quick example. This is the absolute simplest of AIs possible. So sometimes you have the server, but if you can bring the user experience on a device and run in real time, that can make you do things that you could not do before just because of bringing down the latency. So here's an example, an age-old problem. I want to understand what's the object in my hand. Simple problem. How do we solve it? The smallest answer is that we just put a barcode scanner in and get done with it. But the blind person doesn't know where the barcode is to begin with, so how will they scan the barcode, right? So it's usually an exercise in futility. So we said, okay, so we showed thousands of barcodes at different angles, different orientations, different occlusions to the app, taught it, and now added a beeping sound to it. And so it works something like this. Okay, so which is the can I have in hand?
Process Coca-Cola 6CT.
So the beeps ended up being guidance mechanisms, but it worked because it's running at close to 40 frames per second. And so we can play around with the sounds, and imagine if you had object detection, the closer you get to the barcode, the more sound it will get, and kind of act as a binary guidance mechanism, like binary search. To do this before, you had to buy a $1,300 barcode scanner and carry it along with you. And now you can do this for free. Let me put it in more context. A charity raised $2.5 million to give away these 1,300 barcode scanners. And now you can do that for free because of the power of AI running on device. So we trained it using custom vision on the cloud, put all the photographs in, and the system, you can export the model and run it on a device. And so the power is, again, with the developer of what they can possibly do. And this makes a lot of sense. Another quick example being
130.
so it's OCR, but OCR running in real time at a couple of milliseconds. So because we are able to run OCR frame by frame by frame by frame, being able to understand what's in the frame, we can then decide, is it worth speaking, and have we already given the information before? So when we launched it, we thought the good examples will be that, okay, you can sort your mails, is it junk mail or is it the actual bill you have to pay? But we heard some really creative examples. Many users actually put the phone on a tripod, pointing towards the television screen, and have started watching Korean movies because the phone is reading the subtitles in English. Like, how cool is that? Another example is people now sit at the back of Lyft and Uber, put the phone pointed towards the window, and are now discovering the new businesses that have opened in their neighborhood. Because as the car is going, the phone is actually telling them all the different businesses and their logos. And with a good quality OCR, that's the power you can get, and it's in your pocket. So the story here is that we have things in the cloud, and slowly we start to optimize them to bring it to the devices, and then have other developers also start to using it. Now, there's another third really cool example. When we talk about faces, face recognition for the blind community would be like a obvious example that should be done. So why is not somebody doing it? So we said, let's do that. So before Apple had the Face ID, which only runs on an iPhone 10, we basically had a face training system on device. So all you do is you basically take 3 photographs at different angles, maybe different lighting. You add up a name to it, and the next time the app will see you, it will speak out your name. So maybe let's see it in action.
One face near center 5 feet away. Eugene near center 5 feet away. Process, 37-year-old male with a mustache wearing glasses looking happy.
So there's a professor who has taught her entire classroom's face to the app, put the phone pointed towards the door so students cannot sneak in anymore. And that's like a common example of how people use it. Another example being, so one of the cool things that comes with this is that it's not that you can just run it on an iPhone 10, you can run it all the way from an iPhone 5 on device, because many of the people in the blind community might not be able to afford a new phone. So the fact that by bringing these models on device, just to show the power of the model, it can actually recognize between 1 million distinct people. That's what it's tested on. So that's how Uber uses it in their for testing their drivers, and Uber has 7 million drivers, last I heard. So we're trying to bring the same things on device and try to run them in a couple of milliseconds to make these experiences. But because we got this running in real time, the day we launched it, suddenly we started noticing that people, blind users, were posting photographs online because they were getting this guidance of where the person is in the frame. Are they in the center? How far are they away? Are they like 10 feet away, or they are like 1 feet away, so to get your medium distance? And then they take the photograph. If the person is not smiling, they scold them, retake the photograph, and then upload it to Facebook. So we had the whole blind photographer thing actually becoming real. That was exciting. This is the last example, but really cool. So far, Seeing AI was trying to make the physical world more accessible, right? But we said, how about we make existing apps on your phone accessible? So a common problem is that a blind person is browsing Twitter, and as long as it's text, it's easy. The screen reader can read it. But the moment you have an image, what do you do with it? So we started to say, okay, all these memes are not making sense. Let's start making sense of them. So let's see what happens. So you're on the app like Twitter right now. You just tap on that image and share it with Seeing AI. And within Twitter or WhatsApp or mail, it will just start speaking. It has a voice to it. What the text is there, and what the, who the person is, and especially with journalism, you have a lot of celebrities in it. So instead of just saying a raw, dry caption, it goes more in details. And this opened up a whole new world for our audience, which we never imagined of how big this would be. Memes are making sense now, which did not make sense before. And that's the power that if you have an OCR, which is built with deep learning, which is not exactly correct text, but a little bit squiggly here and there, it just goes and does things. We heard an example of somebody who recently was reading JFK files back from JFK murder mysteries, if you say. And the text there was written on a typewriter, which was not actually imprinted nicely. And they were able to use this deep learning-based OCR to actually understand this at a much deeper level and solve something. So that was exciting. So I think I was explaining that all these examples of what Seeing AI does, but to keep in mind that Seeing AI is not a demo app that we built. We actually built it because we have been trying to run deep learning on device since 2014. We had a company-wide hackathon. We said, what can we do? And we basically built a cell phone duct taped to the head, which could speak to you, talk to you. Since then, things became more and more better. So we had a research team of 3 people. But the hardest part we often have is how to operationalize things, because we just don't have the bandwidth. So we often use cognitive services as a place where we sometimes ship the things, and the API comes back to us, and other developers have value. At the other end, see how the state of art can be kept on improving year by year, like you see with the closed captioning system. The other story is that a lot of teams within Microsoft had these state-of-art models, but they were just using it for their own team. So Xbox was using one model for their stuff, Bing was using another model for their stuff. And so one day they decided, why don't we just mix it and just give it out, because other developers might have a value. So that's what cognitive services came out of that particular effort. And as you can understand, it's not just building pre-canned APIs, but custom models that you can train. With 30 images, you can train a custom object classifier in under a minute. If you have 5 images, you can create a custom object detector on whatever your problem is. But you get it back within 1 minute. And if you have used transfer learning, you know that you have to wait for still a couple of hours to maybe a day to get the real good model. But this happens within minutes, and that's one of the optimizations on your problem. So I think the key part that you should take away from this is, what is the power that developers have on the applications that they can build with the state of art in computer vision, whether it's on cloud or whether it's on device. So thank you from Jin and I, and we enjoyed the session. Thank you.
Wow, that was super, super impressive. I love that app. It's fantastic. So do we have any questions for Jin and Anirudh? If not, yes, there we go.
I was fascinating. The question is the processing that you're doing, is it, you mentioned an example of somebody in Puerto Rico walking through, and the first thing I thought to my mind was, there was no cell phone service, so how did that happen? Did all the processing get done on this little ARM Cortex chip that happened to be on their iPhone 7, I'm assuming they had? Mm-hmm. Or where is the cognitive happening? I get the training part, I get the uploading, but are you actually doing it on a device, a 32-bit core device?
So it's a hybrid mechanism. For some of the things that we can run in real time, we get it running on the device. But for some of the heavy hitting things, so the example of the scene understanding, that would just, the language model size on that would be humongous to run on a device quickly. So for that, we run it on the cloud. So in their case, they actually had cell phone signal, although weak, but they had it. We also do a lot of optimization so that network speed is fast enough in the background. So that also there.
And all of this I can test up
Yeah. The nice example is that you can just go to the website. They have some demos where you upload an image and try it out. And then at the exact same time, for some of the things, if you do custom, like build a custom model, you can export it in, for Android, let's say in TensorFlow format. If it's Apple phone, you can export it in CoreML format. So you can bring some of the APIs onto your device if it's a custom model. In fact, the thing that I realized is we submitted the slides about a month back when we couldn't announce anything. So we didn't actually update the slides with all the cool stuff that was there. If you go to the website, you can see just making a bounding box, 5 images, and it's learning that. That was pretty impressive for any engineer.
Okay, any other questions? Oh, there we go.
Yeah, so I had a question regarding the models, right? So, and the API. So you just mentioned it's like hybrid, but like for a lot of the facial recognition, classification, gender classification, etc. Do you think that model can run offline? And the other question I had was regarding with the API pricing model.
Yeah.
If you're running it on off real-time cameras, doesn't that become like a huge cost in terms of frames per second?
Beautiful question. So, so first going towards the face recognition part, right? A lot of the questions are basically about recognizing in your database. So if, let's say, this was an employee problem, right? You have, let's say, 10,000 employees. You probably want to consult a database somewhere of sorts. So imagine you have these images up in the cloud and you're just trying to do verification. That would be a single API call for that example. So that's the one part of things. The second part was doing it in real time, right? So you don't need to do everything in real time. If you come to the Microsoft booth, we actually, again, announced something which we did not include in the presentation. It was basically an example of how on IoT you can run things in real time with whatever model you have. So the particular example we have is something called a new camera, which is called the Vision AI Dev Kit, visionaidevkit.com. And the idea is that, let's say you are an expert at building CNNs, which are doing whatever. You go on Azure, you train however you want, or you bring your own model. And with the press of a button, you deploy it to 10,000 cameras, which can run some of this processing. And so the particular example we have is running a Qualcomm chip with DSPs. And we are running object detection at close to 30 frames per second, but on a problem that was made by the developer specific to their problem. And then once it has detected those bounding boxes, it's uploading back to Azure IoT the rule-based system. So if you were working in some particular, in your home, you wanted to just build a camera which tells, if the cat goes out of my room, send me the alarm bell. You could do that. And that's like one call to the cloud to just tell, or like send your phone. But if you're like, let's say, working in a trucking company, a freight company, and you had 1,000 drivers doing something, and you had cameras there, you could technically be only sending the things that are based on your rules. So real-time processing happening on your edge device, and then the analytical parts being sent to the cloud. So that's a common thing these days in IoT.
So I can also elaborate a little bit more directly to your question. I can't really publicly share sort of exact status we're at, but I'm just going to say that I hope this presentation give you a hint of the direction that we're headed. And please check back with us periodically, and hopefully we'll deliver even more useful things for the use cases that you actually mentioned.
So one of the cool things is that we often look for partner stories of how developers and companies are building cool examples to showcase. So if you have a nice example, you can contact Jen, and maybe we can see what else can be done.
All right, well, thank you. We've run out of time, so if you have more questions for Jen and Anirudh, please get them after the break. So let's give a round of applause for our speakers. Thank you.
Thank you.